Hello, today we're going to dig into our first activity called magnets. This is from our Forces, Matter, and Energy kit. Now, this is our first activity, so this is the first chance for students to start to explore a very abstract concept, which is magnetism and the fact that magnets can cause things to repel and attract. So the way we do this activity is in that inquiry style. We really want to have students start with what they're experiencing. And as teachers, it's our job to help put those pieces together on what is happening. So we're going to begin the activity. Part one is called Magnets and Magnets. And the first thing that the students do is they get with a partner and we hand them each 2 bar magnets. The bar magnets are pretty simple and they have little N's and S's on them. And the only challenge at this point is to have them with their partner work together and explore what they find when they play with their magnets. And they'll notice sometimes they seem to stick together and sometimes they seem to push each other away. Those are the kinds of things that we want students to experience. At that point, we get them together and have the students share what types of things that they found during their exploration with the 2 magnets. And they'll notice things like when the 2 S's were together, it pushed against each other, and when the different letters were together, they attracted each other. This is when we introduce the terms repel and attract. We always like to introduce the terms after the students have had a chance to explore them first on their own and try to explain them on their own. So now, using the terms repel and attract, students can start to put things together, like if they have the same letter, they seem to repel each other, and if they have a different letter, they seem to attract each other. Those are the kind of challenges or some of the goals we want in the beginning. We're not getting into what's going on or what's happening. At this point, we're just trying to build that basic conceptual understanding. So the next part, well, actually the same part, part one, is take the bar magnets away, and we have a new magnet, which is a donut magnet. Same thing, it's magnetic, but there are no N's and S's, so it makes it a little challenging, but they get to do the same thing that they did before. Sometimes they can make them repel, and sometimes they can make them attract. So allow the students an opportunity to feel these different magnets and see if they can identify ways to make them repel and attract. The next part is to put all the 4 magnets together, and the cool thing here is they can start to see what happens if an S is touching there. What does that tell you about this part of the magnet? And students can start to understand, well, if it's attracting, there must be some type of N, or for lack of a better term, a different charge that's being put out by this magnet because they're different, so they're attracting, which is the opposite of if they were repelling. So this is an opportunity for students to continue to explore the idea of magnets' ability to attract and repel, and we can start to introduce the terms poles and introduce them as north and south. Getting into all the science and all the specifics at this point probably isn't appropriate. Okay, we're still in the magnet activity, but this is part 2. It's called Magnets and Materials. And now, instead of looking at magnets and magnets, we're going to start to look at what magnets are attracted to. So the first thing we have students do is go around the room, give each student a bar magnet, go around the room and see if they can find things that the magnet attracts to, find things that the magnet doesn't attract to, and have them go around, and they're going to find lots of things that they are probably pretty not surprised by, but they're going to find a few things that's going to surprise them. There's going to be some metals, some things that are something that they would expect to be magnetic from what they know, and it's not going to be magnetic. Those are the kinds of things that we want to have happen so we can start to introduce the terms or the idea of what magnets are attracted to. For example, I have a clamp light here. I was just playing with this earlier, and clamp light has something that's magnetic and something that's not magnetic. You'll be surprised around your classroom how many things are not magnetics that students might find to be magnetic. So have the students do that, have a conversation about that. Hopefully students start getting the idea that seems like magnets are attracted to metal, but not all the time. And that's the kind of the questions that we want to have to help drive the lesson. So what we do is we give them a bag of magnetic test items. Your kit comes with a bunch of these. And I went ahead and put all the materials out. Those are the materials that are in the bag. They have a student data sheet which lists all these items, and their challenge is to look at each one and predict whether they think it's magnetic or not. teacher tip here, important teacher tip, before you hand out the magnetic test item bags, make sure you collect the magnets. So collect the magnets, have each student, have them work in pairs, look at the items, pick them up, hold them, and make a prediction whether they think it's magnetic or not. Once they've made all their predictions, go ahead and hand out the magnets and have them test them all. They're gonna find some that are pretty surprising, like this rock is magnetic, which is one that's usually gets people to kind of wonder what's going on there. This rock is not. When it comes to the metals, not magnetic, not magnetic, is magnetic. What's going on there? So give the students a chance to make their predictions, test them all out, and then have that conversation where students get a chance to start thinking about what's happening here. We have them in the teacher's guide, ask them to write some rules. What are some things that your magnets can attract, and what are some things that your magnets cannot attract? This is where it gets a little tricky because students know that it typically has something to do with metal, but they're not quite sure. And that's where these three pieces really come into play. One of them's brass, one of them stainless or aluminum, and then the other one is iron. And it's a good opportunity to start to get kids to start understanding that in order for something to be magnetic, it needs to have iron in it. So this rock here, magnetite, when it was formed, actually is formed with iron in the rock. And that's why it's a naturally occurring magnet. So this is an opportunity for students to, again, build that conceptual understanding. We were looking before at repulsion and attraction, and now we're looking at what are the factors that are a part of something being magnetic. At the end of this activity, there is a literacy connection where students have an opportunity to write a paragraph based on a clever fourth grader who put together a idea on how to sell her new product, her new tool. And I'll let you guys take a look at it in the teacher's guide, but it's a good opportunity for students to take what they've learned and have an opportunity to write a response to someone based on the scientific understanding that they have. All right, the next activity, this is the third part in the magnets activity. It's called the floating paper clip. And what you need to do is have students cut off a piece of string, tie one end to the paper clip, and go ahead and tape the other end. You can tape it right to the desktop or the table they're working on. I have it on a piece of cardboard here just because it's easier to move around. So go ahead and grab a couple donut magnets. I have 3 for this one just because it makes it a little bit easier to see from the camera. And once you get the paper clip suspended, it'll be holding there all by itself. Got a good view of that? And now you have the students show them this magic trick, ask them, you're going to try and cut this force here and ask them what they think will happen when I place this in between the paper clip and the magnets. After the students make their predictions, go ahead and test it out. And you can see, doesn't look like the index card did anything to the magnetic force. So this is the same thing we did last activity, use the same magnetic test items and make the same predictions, but this time the question is, if we use these items, can we break the magnetic force that's caused by the magnet? And so what they would do is they would predict each one and then test each one. They might want to hold the weights down or the magnets down because they can move when you break them. So aluminum has no effect. Iron does. So once again, really cool opportunity for kids to see it, explore, ask questions, make predictions, and then test out what happens. This allows us to go to the last part of the activity where we have these opportunities for them to see this force field. Obviously, students are getting a really clear understanding that magnetics create a force, and we can see that through the experiments and the things that we've done today. Using this magnetic viewer with these iron filings in here, your students are able to take a magnet, put it on there, shake it around, and start to, if you can see that, is that okay? Can you see that? Start to notice the magnetic force fields of the lines that are created. And there's diagrams in the teacher's guide that show the magnetic force fields for the donut magnets and the bar magnets. but this is an opportunity for kids to see them using the magnetic viewfinder. So those are the three activities that have to do with magnets. It's talking, it really focuses on repulsion, attracting, and it also talks about things that are magnetic and things that aren't magnetic.